Hey, so hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 says that an aqueous solution is 2.65 moles per liter in tartaric acid, C4H6O6. The solution's density is 1.016 grams per mole or grams per milliliter. Calculate the solution's molality, the mole fraction of tartaric acid, and also its percentage by mass. Okay, so this is a multi-step question. And first we need to calculate the molality. So define what molality is. Similar to molarity, it kind of describes the concentration of a solution, but molarity is in moles per liter, whereas molality is in moles per kilogram of solvent. So let me write that down. Molality is the number of moles of solute per kilogram of solvent. Okay, so first to calculate molality, step 1 is to calculate for the mass of our solute. So we know the concentration is 2.65 moles per liter. So first we need to assume that we have 1 liter of solution. And this will help us because we can just assume that we have 2.65 moles of tartaric acid. So to calculate for the mass of the solute, we just need to use the equation where mass is equal to number of moles times the molar mass. So if we assume 1 liter of 2.65 moles per liter solution, we know that the number of moles is equal to 2.65. But now we just need to find the molar mass of tartaric acid. So let's try to do that at the bottom here. The molar mass of tartaric acid, which is C4H6O6. To find its molar mass, we just need the different atomic masses of all of the atoms involved, and it's going to be equal to 4 times the molar mass of carbon, which you can just find on the periodic table for these values, 6 times the molar mass of hydrogen, plus 6 times the molar mass of oxygen. So the molar mass of carbon is 12.01 grams per mole. The molar mass of hydrogen is 1.01 grams per mole. And the molar mass of oxygen is around 16 grams per mole. Okay, so if we add all these values up, we get around 150 grams per mole as our molar mass of tartaric acid. So now we can plug it into our equation and do 150 grams per mole. So if we multiply the two, we get a mass of solute equal to 397.5 grams of tartaric acid. Okay, so we know the grams of tartaric acid. I'm just going to start a new page just so that we can make more room. So we're still on part A, finding the molality, but step 2 of this solution is to calculate the mass of our solution. So we know that density is equal to mass over volume. So we can rearrange this equation to find the mass of our solution. And we do that by multiplying density times volume. So the density is given in the question. So it's 1.016 grams per milliliter. So again, we wanted to assume that we have 1 liter of solution. So 1 liter converted to milliliters is 1,000 milliliters. And that's just to cancel out our milliliters. And we have 1,016 grams of solution. So now we have the mass of our solute and we have the mass of our solution. So now we have to find the mass of our solvent. Find mass of solvent. So the mass of our solvent is equal to the mass of our solution. So the mass of our solution contains both water and our solute. And we subtract the mass of our solute, which we found in step 1. So the mass of solution we found to be 1,016 grams. And the mass of our solute, it's on the previous page, 397.5 grams. So this gives us 618.5 grams. And when we calculate molality, we want the units of solution of solvent in kilograms. So let's just convert this to kilograms. 0.6185 kilograms. Okay, so now step 4 of part A is to find the molality. Molality. So molality can be denoted as lowercase m, but Just don't get it confused with mass. I'm just going to write the equation here. Molality is equal to 2.65 moles. So this mole value stays the same. And now we just divide by the mass of our solvent, which we found was 0.6185 kilograms. And we get a final molality of 4.28 moles per kilogram. Okay, so that was just part A of question 1. So now let's start a new page and answer part B, which is what is the mole fraction of tartaric acid? So for the mole fraction, we can write down the relationship between the mole fraction and molality, since we calculated the molality in the previous step. So the relation between the mole fraction and molality can be expressed as the following, where the molality is equal to the mole fraction of our solute times 1,000 divided by the mole fraction of our solvent times the molar mass of our solvent. Okay, so let me have a side note here. We know that since the mole fraction of our solute plus the mole fraction of our solvent is equal to 1, then we can actually write the mole fraction of our solvent equal to 1 minus the mole fraction of our solute. And the reason we want to do this is so that we only have one unknown in our equation. And this will help us just solve for x. So now let's sub in all of the values that we know. We know that the molality is 4.28, which we calculated in the previous step. And we're trying to solve for x. So we have x times 1,000 divided by, now we sub in 1 minus x times the molar mass of our solvent. So the molar mass of our solvent is water. So the molar mass of water is equal to 18.02 grams per mole. So then we just plug that in as well, 18.02. And now we just need to solve for x. So multiplying this in and then bringing it over to the other side, you get 4.28 times 18.02 minus 18.02x is equal to 1000x. And then if we solve for x, you should end up getting 0.0836. And this is the mole fraction of tartaric acid. Yep. So if this X is equal to the mole fraction of our solvent, then to find the mole fraction of our solute, it's just going to be 1 minus this answer. So let me just say this is for solvent. So X solute oh wait, this is actually the mole fraction of tartaric acid, sorry. Okay, so our final answer is just 0.0836. And now for part C, calculate the solution's percent by mass. I'm just going to denote it as mass percent. And for this question, to solve it, it's just going to be the number of moles for our solute times the molar mass of our solute. So this will give us the mass. And we divide by the density times 10. And the reason it's times 10 is because it kind of simplifies it since density is in milliliters. If we were to convert to liters and then multiply by 100, it's the same thing as multiplying it by 10 in the denominator. So then we can just plug in the number of moles of our solute, which is 2.65 moles. The molar mass of our solute, 150 grams per mole from part A. The density is 1.016 grams per mil multiplied by 10 gives us a final mass percent of 39.12. Okay, so this is a long answer. So let's start from page 1 and see what the junior tutor said. So tartaric acid with a chemical formula C4H6O6 is an organic acid that occurs naturally in many fruits, especially in grapes. In this problem, the given quantities are molarity, which is 2.65 moles per liter, and density 1.016 grams per mil. We are asked to find the following. So molality is the number of moles of solute per kilogram of solvent. Okay. So to calculate molality, step 1, calculate the total mass of solution using the given density of the solution. Okay, so they did this step first. They multiplied the density by 1,000 to get the grams of solution. Step 2 is now to calculate the mass of the solute given the molarity of tartaric acid. So this is my step 1. So if we have 1 liter of solution, you have 2.65 moles. They calculated the molar mass, which was 150, and also got 397.5 grams of tartaric acid. So now step 3, our step 3s are the same. Calculate the mass of the solvent by subtracting the mass of the solute by the mass of solution. So they got 0.6185 kilograms of solvent. And next, we need to find molality. 2.65 moles divided by 0.6185 kilograms gave 4.28 moles per kilogram. Okay, so now for part B, for mole fraction, molality is related to mole fraction as given in the expression below. Okay, so they have the same equation where x is the mole fraction of the solute, and they made 1 minus x as the mole fraction of the solvent. Molar mass of water is 18 grams per mole, and then they also solve for x. Looks like the math is correct. Might be off by a few decimal points. Let me search calculator. So they got around 0.7, 0.07, which is close, but I think it's a little different than mine because they have a molar mass of 18 grams per mole instead of 18.02 grams per mole. So that's why there might be some differences, but the solution looks correct. And then for the percent by mass, we have the same expression, moles of the solute times the molar mass of the solute divided by density times 10, and they also got 39.12%. So the solution is correct.